Double the wind speed, you get 8 times the power out of it. So there's an enormous benefit to going up higher. The problem is, if you build one of these big towers, and you've seen them out there, the big ones have a hub height, that thing that the blade goes around is about 100 meters, about 300 feet. Those towers weigh between 200 and 400 tons. Building one of those, moving it to the site, which often requires widening roads and all kinds of crazy stuff, putting it at the site, you actually have to have a whole foundation for each of these things, I mean a financial foundation, to pay to have it plugged away at the end. That's an incredible amount to spend. And here's the horrifying thing. Going up is almost taking the weight of this thing up with the cube of the linear height. That is, if you double the height of one of these towers, the weight of it goes up by almost a factor 8. So there isn't as much benefit as you would intuitively think about going up if you build a tower. But the thing that we're going to start flying next month weighs 1% that much. So the way that this works is it sits on a perch. It looks like the wingspan of a large airplane, but with no body in the middle. It has 8 propellers on it, and it lifts off and it pulls out a tether behind it, and it's pulling power up the tether to drive these propellers. It actually works, it looks a lot like that tail sitter we were talking about. But once it gets out to the full length of the tether, which will be about 450 meters, it starts doing big circles in the sky. And then, instead of pulling power up the tether, it puts drag on those 8 propellers, turning them into 8 flying wind turbines, and sends 600 kilowatts back down the tether continuously. When we first were starting to work on this, instead of building the 84-foot one, which is what we're about to start flying, the full-scale version, we built a smaller version, which was 28 feet long. And that was to test out all the flight modes, to make sure that it would be very stable in lots of different winds. And Larry Page said to me, make sure you crash at least 5 of those test versions of the vehicle. Now, obviously, he wants us to be safe, and we work super hard to be safe in everything that we do. What he meant was, if you're not failing at least some of the time, you could be learning faster. If you're not breaking your experimental equipment at least some of the time, you could be learning faster. And I know he's right. So we picked one of the gustiest, windiest places in North America to test this 28-foot scale model, which is what you can see flying there, at a place called Pigeon Point in Pescadero, California, where the speed of the wind can change by 20 miles per hour in a second or 2, and where the direction of the wind can change by 90 degrees in a second or 2. And we learned a ton from the 100+ hours of flying we did. But we failed to fail. We didn't crash, not once.